Now, when we are pretty much aware of many different ways the technology, the platform, and the web server infrastructure can be compromised, let me push that even further. So even if the design architecture, the creation of security controls and the implementation of the web application results in no vulnerabilities of all the types and classes that we have just discussed, it is still could be possible to compromise the web application completely. Okay, so why? uh, that's the good question, and the answer is pretty much the same. Because someone thought that it will work this way, but there are certainly other ways of that things working. So this is a lack of proper planning, I would say. So some type of security threat modeling exercise were just missed or performed incorrectly. So once the high level review of how things should be in the web application and how they should be protected just went missing or produced incorrect results. Yeah, so we just completely missed some threat, yeah, that we as penetration testers and black hat hackers could pose to the web application. For example, let's say there is a web service that is accessed by two types of client side applications: the web application that is loaded into the browser and the mobile application that is run on different mobile platforms. So let's say security controls, yeah, the functionality that should sustain those threats and attacks for those two different client-side applications were created by different teams. Okay, so one team of front-end developers completely narrowed down to JavaScript, AngularJS developers and testers, and one team of Android developers and one team of iOS developers, and some functional testers for both of them. So imagine that. So that's pretty realistic, because that's what happens normally. Yeah, and imagine that people who were thinking about the web, of course, were not aware of some architecture and platform specifics of mobile applications. Okay, and the people who were thinking about mobile applications were not thinking about what's going on in the web world. Okay, in that particular case, so they were focused on making the things work on their platform of choice. So the web service at the same time were quite indifferent. Yeah, so they were not the web service development team were absolutely not interested of what's going on those client-side applications. Yeah, so they just provided the API and thought about how to make that work in the best way possible. And then a guy like you, yeah, comes in and reviews all what's happening and understands that some things that are within the specifics of this API, yeah, and are common between the web application and the mobile application, miss mobile application specifics. For example, there is this insecure logging, yeah, that's going on in a mobile application and is absolutely impossible on the web application. And since the threat model and the resulting security controls is the outcome of this joint effort of those three teams, yeah, and it just covers everything that relates to all of them, yeah, simultaneously, and completely leaves outside the focus of what is specific to each of them, yeah. The mobile application team were just left alone with those problems, and they didn't deal with them properly. and you find that basically application just logs a lot of sensitive data to the system log that is by default available by every application running on the same system. Okay, so you just mount an attack of deploying a specifically crafted APK to the Android operating system and intercepting a lot of sensitive data that is just left over, yeah, but can pose a certain threat to the data, yeah, that the application processes. So this could be one example, yeah. So just not thinking long enough and lack of attention to application platform specifics can result in the business logic vulnerabilities. What else? So all that can be result of poor business analysis of what's going on in the process, yeah, of poor threat modeling, of poor risk management exercise. Okay, so that all more on the business side of software world, right? So that is more of a business function, not developer function, and this is where is the root cause for all those troubles. So what can you do in order to identify those blind spots where business logic vulnerabilities may reside? So first of all, it is important not to start hacking application right away. It is very important to start from just using the app in the way it's intended to be used by legitimate users. So first thing you do is just reviewing the functionality. You go through all the paths you could take in your current situation with the current credentials you are provided with. You just went through a public registration for the web app, or you just received some test credentials from the application owner, whatever. So you just go and see what it does, what are different functions. You of course log all the traffic that is passed from you to the server and back, and you review what's happening, yeah. So how all those different steps are taking, what are the sequences between them, and then you just start to temper those sequences a bit, right? Trying to take later steps before completing previous steps and so on. So just from that you already can maybe create some risky conditions for the web application execution. So while you do all that, of course, you review the protocols and the specifics of communications that is going on between the client side and the server. So what is the possible logic flaw in there? So let's say very popular thing that is used for this client server specific web applications, yeah, when the server is basically a web service with an API, is so-called Java Web Tokens. So it's an authentication scheme when everything you need for authentication authorization is passed with each of your requests, but it's encrypted and with a key that is known only to the server. Okay, so it just gives you that, and you are supposed to carry it on through all the session and present it all the time you want something from the service. Okay, and it's signed, of course. It's signed and then encrypted, or the other way around. No, it's not very important in this particular case. So there is like a checksum, like a signature in the end of the token, and if you modify the other parts of the token and successfully forge the signature, you basically can manipulate your role. Okay, you can just be someone else when this request arrives to the server, and the server will believe you. And what is used for encryption and the signature key sometimes is just the public key of the HTTPS of the SSL certificate on the web server. Okay, so that's unfortunately what's happening sometimes. Sometimes just the zero key, just the null key is used, and everything is completely reversible. But sometimes just easily guessable key is chosen for this highly critical operation. So this is one case of possible business logic flaw. It can be classified as misconfiguration as well, but here what should have been really secret is underestimated and is cognitively guessable. Okay.